let's continue on. All right, it wants me to sketch the graph of this and state the domain and range. Okay, so remember whatever's under the exponent, first of all, it's called your b. It's your base. And if this number is bigger than 1, we have growth. Is this bigger than 1? No. So since this is not bigger than 1, it's somewhere between 0 and 1, this means this graph is decay. And decay goes like this. So which picture looks like it does that? D. D is the only one that does that. So I don't even need to put it in the calculator. It does say the domain is all real numbers, which is always, always, always the case. And it says the range is all positive numbers. So what that means is the graph is getting close to a y value of being 0. And then it goes up, 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 which means y's are getting greater. And so when it says range is all positive numbers, well, yeah, if it's everything bigger than 0, then that would be all positive numbers. They just kind of worded it a little differently than you're used to seeing it. But just knowing that this is decay lets me know how the picture is going to look. Now, if this number had been bigger than 1, it would have been growth, and this would be my answer. And then, of course, you could always go to y equals, and you could type it in if you wanted to see the actual picture for yourself. You could always go to y equals, type in your 1/3 raised to the x, and you could see the picture, which is D. All right, moving on. All right, number 11. All right, determine whether this function represents growth or decay. Okay, so it's all about the b. So whatever's under the exponent, that's the base. If it's bigger than 1, it's growth. And if it's between 0 and 1, it's decay. And that is between 0 and 1. And if you don't know what 2/3 is, you can go to your handy dandy calculator, put 2 divided by 3 in there, and you can see that that is not bigger than 1. It's somewhere between 0 and 1. Okay, now we're back to doing what we did on the first page. I need to get these to be the same base. Okay, so let's check a base of 9 out. So this would be 9 to the first. Let's see, can 9 to something get me 243? Too small, too big. Okay, a base of 9 is no good. Let's try a base of 3. So I know this is 3 squared, right? Now let's see if we can get this. 3 to the 5th. That's it. So I'm going to write this one as 3 squared, and I'm going to write this one as 3 to the 5th. Okay, so this guy is 3 squared, and this guy is 3 to the 5th. And I have an equal sign. Okay, so now I'm going to recopy the exponent. So in parentheses, 4x plus 4, and in parentheses, 2x plus 2. Okay, so I know if these two bases equal, then the two exponents equal. So this exponent, 2 times 4x plus 4, equals this exponent, 5 times 2x plus 2. All right, let's distribute to get rid of those parentheses. So when you distribute the 2, you get 8x plus 8. When you distribute the 5, you get 10x plus 10. Okay, I need to get my x's on the same side. I'm going to move the smaller one. So to move the positive 8x, I do the opposite and subtract. This zeroes out. Drop your 8. Drop your equals. 10x minus 8x is 2x. And drop the 10. All right, looking on the side of the x. Next, I'm going to get rid of the addition of 10 by subtracting. The 2x drops. The equals drops. And 8 minus 10 makes negative 2. So now I would divide by 2. And if I divide by 2, I get negative 1. And that's my answer. X equals negative 1. All right. Now, remember when you see the fraction, you need a negative exponent. So this would be 6 to the negative 1. If you don't understand, you could put 6 to the negative 1 in your calculator. Just know that fractions need negative exponents. Math, enter that, and voila, it's 1/6. Okay, so this is 6 to the negative 1. And this, of course, is just 6 to the first, I guess, if that makes you happy. And then this one doesn't have an exponent, so I'm just going to recopy that exponent. Okay, so now it's like the others. If this base equals this base, then this exponent will equal that exponent. Okay, so this exponent, negative 1, will equal this exponent. Now, 1 times n plus 4 is just n plus 4. So that's all I'm going to write is n plus 4. And then this is easy peasy. Get rid of addition of 4 by subtracting. The n drops. And negative 1 minus 4 is negative 5. And so that's my answer. N equals negative 5. Okay, 14, same kind of thing. All right, now what base will they be? What do you guys think? A base of 2, a base of 4, a base of 8. I say let's try the 2. 2 to the 5th, got the 32. 2 to the 4th, got the 16. There it is. This is 2 to the 5th, this is 2 to the 4th. Okay, so 2 to the 5th, this is 2 to the 4th. All right, now let's write our exponents. So this exponent I'm going to put in parentheses, and this exponent I'm going to put in parentheses. Okay, so I've got my bases the same. So now we're going to work with our exponent. So this exponent this time will be less than this exponent. So 5 times x, or 5x, is less than 4 times the quantity x plus 2. Okay, let's distribute that 4 to get rid of the parentheses. That makes 4x plus 8. Drop the less. Drop the 5x. Need to get x's on the same side. He's alone, don't move him. Let's move this guy. So to move a positive 4x over, we subtract. So 5x minus 4x is 1x, or x. Drop your symbol, drop your 8. I've never multiplied or divided by a negative number, so no signs flip. But if I had divided or multiplied by a negative number, then I would have to flip my inequality sign somewhere, but that never happened. All right, number 15. What is the amount for P principal that should be invested at 7% per annum, compounded annually, so that $3,000 will be available after 9 years? Whew, lots of big words. Okay, so 9 years is our time, so that's T. N is how many times it's compounded in a year. So if it's compounded annually, that means it only happens once in the year. So that means N would be 1. The percent that we get, that is our rate, but I need to know what it is as a decimal. So right now, the decimal is to the right of the 7, because you don't see it, and we have to move it twice to the left. So once to the left makes 0.7. We need to add a 0 to move it twice to the left. So that would be 0.07. So that's my rate. And $3,000 is the amount we want to have after 9 years. So this is our A. And we're solving for principal, which is what you would invest. So that's what we're trying to figure out. How much money do we have to invest so we have $3,000 after 9 years? Okay, so let's put everything in. So into the A goes the 3,000. P will stay P. 1 plus, okay, my rate is 0.07 divided by N, which is 1 because it was compounded once in the year. And up here, I'm going to take n, which is 1, times t, which is time, and that is 9. Okay, I am going to put all of this right here in my calculator. All right, here we go. Parentheses. 1 plus alpha y equals it. Enter. 0.07 goes on top, arrow down. 1 goes on bottom. Right arrow out. Close the parentheses. Raise it to the power of. Now this is easy. 1 times 9, that's just 9. So I don't need to type 1 times 9. That's just 9. Okay, hit enter. Okay, so this is what's multiplied with the p. So it's like 1.838459, blah, 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 p. And then that equals my 3,000. So if you wanted to get p by itself, how would you get rid of this? You would divide. You would divide both sides by what is multiplied with your p. So I'm going to divide both sides by that. But I'm not going to write all that in my calculator, okay? So this is what I'm going to do. I'm going to take this 3,000, so 3,000, and I'm going to divide by this answer. So instead of having to round it, I can just keep it the way it is. So to pop up this answer, I go second and the negative, because there's A and S above it in blue. So second and then the negative. So it's 3,000 divided by this answer I got up here. And so I don't have to type all that. And this is how much principal we have to invest. $1,631.80. That's how much money we would have to invest, which is answer choice A. So 9 years later, we have $3,000. Not too shabby. That's pretty good growth after 9 years, but we have a really good interest rate. Okay, last question. A culture of yeast doubles in size every 4 years. Determine an expression for the number of yeast, Y, after T hours, given that the yeast population is estimated to be 3 million now. Okay, so if it's doubling, then under the exponent, whatever the exponent is, needs to be a 2. Okay, if it was halving, then whatever was under the exponent would be a half. If it's tripling, this would be a 3. If it was being cut in thirds, this would be 1/3. Okay, so since it's doubling, I need a 2 under the exponent. So this does not have the 2 under the exponent. This one does, this one does, this one doesn't. Okay, so A is out and D is out. Okay, this is the initial value of the yeast population, which is 3 million. So that should be the number in the front. Okay, so both of those are good. Now, for the exponent, because this culture is doubling in size every 4 hours, then the exponent has to be this guy. It is the time it takes out of your doubling time or your halving time, whatever the problem happened to be about. So since it's doubling every 4 hours, you have to take the time total there is and divide by your doubling amount of time. And so C is our answer. And that's it. All right, good luck with this test. Smiley face.